So this morning we're going to talk about transformations of quadratic functions. And the good thing about this is we have seen some of these previously, so we're just going to get into a little bit more, but we're going to deal directly with quadratic functions. So a quadratic function can be written in this form right here. And we've seen this form previously. So we have f of x equals a times x minus h squared plus k. Now if you notice, we have the a, the h, and the k. Those are all constants, and they all represent something. So we have the h, and what the h indicates is a horizontal translation. So a horizontal translation would be moving the function to the left or to the right. And the next constant we have is the a. And what the a indicates is a reflection in the x-axis and or a vertical stretch or shrink. And last is the k constant. What the k constant indicates is a vertical translation. So that means that it can go up or down. So what now I'm going to go through is just kind of a way to represent it. So the first thing that you would read if you were to read this would be the horizontal shift. So you could go left or right. That's the left or the right. And then you go over here, which would be this guy right here, indicates a reflection. So a reflection, as you can recall, would be if you had a parabola like this, and then we wanted to reflect it over the x-axis, so it makes it go downward. Or you could have a vertical stretch. So a vertical stretch would be something if you had your parent function look like this, and then you made it get a little bit smaller or get steeper. Also, you have the vertical shrink. So you can think of this as a vertical shrink. It gets flatter and flatter and flatter as it goes down. So you have a couple different things. You have a reflection, you have a stretch, and then you have a shrink. And then after that, you want to go to the vertical. So you can either go up or down, up or down, up or down. Now you might ask yourself, well, what do we call this? What form is this in? What is it? The parabola form? Is it the quadratic form? No, it's the vertex form. So it's vertex form. And the reason it's called the vertex form is because the h and the k is your vertex. Well, then you might ask, well, what is the vertex? So I'll show you a graph of that right now. So here we have the vertex. If you look at this blue dot right here, that is the vertex. So what point would that be? Well, that would be, let's count. We have 1, 2. So we would have the point 2. And let's figure out what the y is. So 2, 2. So if you look at this, we would have 2, 2. So that would be our vertex. Now what the vertex is your. So what the vertex is right here by definition. It's the lowest point on a parabola that opens up. So if you notice, this parabola right here opens up. So that's actually the lowest point. Now let's say I have a parabola that opens down. You'll notice that this vertex is the highest point. So here's an example of something a little bit different. So what's going to happen is they're going to actually give you the transformation, and you have to tell what the transformation was. So we're going from here to here. So we have to learn. So what I'm going to do is actually write this in vertex form. You don't have to always do this, but I'm just doing it as an example to show you what really is going on. So if you think about it, we don't have a shrink, a stretch, or a reflection, so it's just 1. The a value is 1. It would be x minus, don't have any shifts, so it would be 0, squared, and you don't have any movements up or down. So if you can recall, I'll just rewrite it out as you've seen on the previous page. It would be a x minus h squared plus k. So if you notice, this would be 1, this would be 0, and this would be 0. So now let's look at the g of x. So what did I do with the g of x? So let's go ahead and write the g of x out. You have g of x equals x minus -4 squared minus 1. And we don't have an a value, so we'll just call it 1. So let's look at these shifts. Well, what are my shifts? If you notice, what you can find is you really can look at the vertex. Well, what's the vertex? Here's the vertex. So let's look at the shift on the graph. So if you graph this on the Desmos app, if you look at this, where's the shift? We know that the parent function would start from here. Let's look at that shift. We always want to go left to right first, so it went left 4, and then it went down 1. Well, if you look at the vertex, remember the vertex we said was -4, -1. If you can think about it, what this is basically your translation left to right, your horizontal translation, where this value is basically your vertical shift or your vertical translation. So if you can just find the vertex, you can find out right away what type of shift it's going, whether it's going left to right or up or down. So how you would write this for your answer, so describe the transformation f of x equals x squared represented by g of x equals x plus 4 squared minus 1, then graph each function. So to describe it, you'd say g is a translation 4 units left and 1 unit down of the graph of f. So just look at that, it tells you right here. All right, if you know what this is the left to right, this is your up or down. And then they would want you to graph it, so you'd go ahead and get out your pencil. You guys know how to graph, so I'm not going to go through that, but your graph would look like this, and you can actually see where the movement is. Okay, so now we have another type of example that you'll see, and this is writing a transformed quadratic function. So it says, let the graph of g be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. So what you want to do is you want to break this down. Let's go through it, and let's look at the first thing that it states. It says, let g be a vertical stretch of a factor of 2. So what that vertical stretch of a factor of 2, well, we know that's going to be your a value. Now it's intuitive, so we know it is 2. Now let's go ahead and figure out what the reflection, that's another thing that we know that our a value would be a negative. So we just go ahead and make that a value a negative. And then followed by a translation 3 units down. Well, what's that going to affect? That's going to affect our k value. So our k value is going to go down 3. So we have our vertex form here, and now all we have to do is go ahead and plug these values into that. So I have g of x equals so we know our a value is -2, so we just have to plug that in right here, and then it's going to be x minus, well, we don't have an h value, do we? So we can just say 0. If there's no h value, it's just 0. And then the k value, we know that the k value was -3. So we can just go ahead and now simplify this. So when we simplify it, we bring it all together, we'll have x equals, well, what do we do first? We have to do the inside of parentheses, right? X minus 0 is just x, and then you have to do the exponent. So that would be x squared, and well, what's on the outside of it? -2. And now we want to go ahead and put these two together, or simplify that, and the easiest way to simplify that is -3. So that's how you go about this. Now they might ask you to identify the vertex. Well, if you think about it, what is the vertex? Let's go back. I know that it's the h value in the k value. So the vertex of this problem would really just be 0, -3. So that's your vertex. So hopefully I kept this under 10 minutes for you. If you have any questions, please ask me tomorrow, but remember, come up with your 3 questions, a HOT question, a confusion question, or an example. So keep up the good work, and I will see you guys tomorrow. Adios.